Guess you found me in the comforts of my own home today. Let's get started on topic 2, redox tables.
Topic 2, redox tables. Let's remember back from our last lesson that reactions are a tug of war for electrons. The atom or ion that pulls harder for the electrons wins. So we have to remember the term oxidizing agent and reducing agent, but remember how they are related to being oxidized and being reduced. So an oxidizing agent is itself undergoing reduction. An oxidizing agent causes oxidation by removing electrons from something else. Because it's removing the electrons from something else, it is therefore gaining the electrons and becoming more negative or becoming reduced. So here our silver cation gains electrons to become our silver solid. It has undergone reduction, but it has caused our copper solid to undergo oxidation, becoming copper 2 ions. So a reducing agent causes reduction by donating electrons from another substance. So up until now, you probably looked at a reaction and thought that reactions just happened. But what we saw in the lab the other day was that only certain reactions happen. Those are called spontaneous reactions, and some reactions don't happen. Those are unspontaneous reactions. So we can look at redox tables to help us to predict if a reaction will occur or not. We don't necessarily need to go to the lab like we did the other day. So what we're going to work on today is how to make redox tables. We can look at these redox tables and be able to tell if a reaction is going to be spontaneous and occur, or if it is not going to occur. Metals and anions usually behave as reducing agents. This means they lose electrons for themselves to become oxidized. Metal ions and nonmetals usually behave as oxidizing agents, gaining electrons to become reduced. Make sure you guys have both of these correct in your head. Metals and anions, reducing agents, metal ions and nonmetals as oxidizing agents.
Hi Chem 30s! Welcome to my bathroom lesson in redox tables. So like I said, metals and anions are undergoing oxidation. So these are oxidation half reactions. We can see that our electrons are on our product side. Because metals and anions undergo oxidation, they themselves are reducing agents. And then likewise, what we also said, our cations and nonmetals are undergoing reduction. So a gain in electrons is reduction. So our cations and metals, because they're undergoing reduction, are themselves oxidizing agents.
So for homework, you guys were to write down the 6 spontaneous reactions that happened in the lab. Now I want you to look at those 6 spontaneous reactions and write the half reactions for each of the entities. Then I want you to label what is oxidizing and what is reducing for each of the half reactions, and then which of those entities are oxidizing agents and which of those entities are reducing agents. I'll give you guys a moment to do that. You can pause the video. Okay, Chem 30s, by now you should have your 6 reactions written and then split them into your half reactions, labeling which ones are undergoing reduction and which ones are undergoing oxidation. So check here before moving on to your next step. Here you now have labeled your oxidizing agents, which are your cations, and your reducing agents, which are your anions. Double check that you're correct. Now I want you guys to find this chart in your workbook and fill it in based on your half reactions that we've just written. So look at each of your ions for half reactions and decide how many reactions each of your cations have undergone. So how many times did your copper ion react, your magnesium ion, etc. Then I want you to order the reactivity, 1 being your cation that reacted the most and 4 being your cation that reacted the least. You guys can pause the video right now just as you finish this up, and then we'll go to the answer. So working along with you guys, you can see that your silver ion has reacted 3 times. Your copper ion has reacted twice. Your zinc ion has So by now you should have filled in your chart, and this is what it should look like. So you guys can have a look here. Your cations here, we've rated them all on the number of reactions that they've had and then their reactivity. So if we look back at our half reactions, we know that silver ion reacted 3 times, our copper ion reacted twice, our zinc ion reacted once, and our magnesium ion reacted 0 times. That would make silver our most reactive, then copper, then zinc, and then our magnesium ion with the least number of reactions, therefore being the least reactive overall. Now let's fill in the chart for our reducing agents. So our reducing agents are our metals in this case. How many times did each of your metals react? Based on your half reactions, you guys can fill that in. And then look for your order of reactivity. So you're going to tell me which of these metals reacted the most to the least. So go ahead and do that. You guys can pause the video here, and then we will resume and we'll look at the answer. So just like we did with our cations, let's look at our metals. We can see that copper reacted once as a reducing agent, zinc reacted twice, and magnesium solid reacted 3 times. So let's put So you guys can double check your answer here. So here we've got magnesium metal reacting 3 times, zinc reacting twice, copper reacting once, and silver reacting 0 times. Our order of reactivity then should be our magnesium reacting the most, followed by zinc, and then copper, and then... Alright, now looking at how you guys ranked your strongest oxidizing agents and your strongest reducing agents, I want you guys to tell me which of your substances is the strongest oxidizing agent. This should be the oxidizing agent that has undergone the most reactions. I also want you to tell me which is the strongest reducing agent. So this is the reducing agent that's undergone the most reactions. So quickly look back at your rankings and write down your strongest oxidizing agent, your SOA, and your strongest reducing agent, your SRA. Alright, you guys should have picked your silver ion as your strongest oxidizing agent and your magnesium solid as your strongest reducing agent. Now I want you to look at all of your oxidizing agents and write your strongest oxidizing agent half reaction at the top, followed by your second strongest, your third strongest, and then your weakest half reaction for your oxidizing agent on the bottom. You guys can pause this video and I'll show you guys the answer in a sec. Alright, so let's have a look if you guys got the right answer here. So your strongest oxidizing agent was silver, followed by copper, zinc, and magnesium, and you've written the half reactions for all of these. What I want you guys to notice here is that your strongest oxidizing agent is on the top left. Your weakest oxidizing agent is on the bottom left. However, if we look over to the right-hand side, your strongest reducing agent is on the bottom right, and your weakest reducing agent is on the top right. This is the start of writing a redox table. So it goes strongest oxidizing agent at the top, strongest reducing agent down here on the bottom. Alright, let's have a look at this a little bit more. So using the list that you guys just developed just above, I want you guys just to fill in this part of your next chart that's in your workbooks. So you're just writing each of the half reactions in here. So go ahead and do that, and then we'll go through the answers in just a sec. So by now you should have filled in this chart. This is your strongest oxidizing agent, and then down here we've got your weakest oxidizing agent. So what I want you guys to see is that this is a table of relative strengths of oxidizing agents and reducing agents, also found on page 7 of your data books. Your strongest oxidizing agents are everything that is to the left of the arrow, your weakest oxidizing agent ending on the bottom left. Your strongest reducing agents are on the right-hand side of the arrow, the strongest one being the bottom right, the weakest one being the top right. So, based on the discussion that we just had, what I want you guys to do in your data books on page 7 is find your reduction half reaction tables. And we're going to be using this a lot to figure out if reactions are spontaneous or not spontaneous. So we can see on the top left-hand side, these are our strongest oxidizing agents. So what you guys can do right here is write SOA. These are our strongest oxidizing agents. All the way down to the bottom, lithium here, our lithium cation, is our weakest oxidizing agent. However, lithium solid is our strongest reducing agent on this table. So you guys can write SRA on your data tables to show that these are your strongest reducing agents. Your weakest reducing agents then are going to be all the way on the top right hand side. This fluoride ion is a very weak reducing agent. So let's go ahead now and look at example 6 in your workbooks. So here we're looking at all of our cations on the left hand side. Remember, cations gain electrons to become solids. They are gaining electrons, they're undergoing reduction, and themselves are oxidizing agents. So I'm just going to write a little note here that these are our oxidizing agents. We can see along the top here, these are all metals, and our metals are going to lose electrons to become cations. So they themselves are undergoing oxidation, which makes these guys reducing agents. Okay? Just like we did in our lab, let's look at reactivity. So for our oxidizing agents, our uranium has 3 reactions. Our palladium reacts only once, our scandium reacts twice, and our ruthenium has no reactions at all. So we can go ahead now and rank our most reactive oxidizing agent, our second most reactive oxidizing agent, third, and then fourth. Writing the half reactions, right, for uranium to uranium solid, platinum ion to platinum solid, etc. So very similar to what we had done in the lab, I now want you guys to take this information that we've been given here and make a redox table. So your strongest oxidizing agent to your weakest oxidizing agent on the left, and it should go without saying that your strongest reducing agent will be your bottom right and your weakest reducing agent will be your top right. So go ahead, make your half reactions, line them up from strongest to weakest oxidizing agents on the left hand side, and then double check your answer below. Okay guys, here's the answer. Let me know how you did. So just a few notes on using the redox table in your data book now. So the left-hand side of the arrow in the data book, all of these species are reactants and are oxidizing agents. The strongest oxidizing agent is fluorine gas, and it's at the top left-hand side of the page. Remember that an oxidizing agent will help a substance to become oxidized, taking electrons away from the substance in the process of reducing itself. The right-hand side of the arrow in these equations, all of these species are reducing agents. The strongest reducing agent is the bottom right-hand side of the page. That's our lithium solid, and it oxidizes itself. For oxidizing agents, the half reaction is read from left to right. For reducing reagents, we reverse the reaction, reading it from right to left. When we're looking at our redox table, a spontaneous reaction is going to occur only if the oxidizing agent is above the reducing agent on our table. So if your oxidizing agent on the left-hand side of the arrow is above your reducing agent on your right-hand side of the arrow, then you have a spontaneous reaction. You can predict that the reaction is spontaneous. I like to remember OOT. Oxidizing on top is spontaneous. If the opposite is true, your oxidizing agent on the left side of your arrow is below your reducing agent on the right-hand side of the arrow, then you have a non-spontaneous reaction. When we're constructing a redox table, we need to remember the spontaneity rule. So from the information that we've been doing and from the examples that are coming up, we're going to take our net ionic equation and identify the oxidizing agent and the reducing agent from our half reactions. Remember that metal ions and cations and nonmetals are oxidizing agents. Nonmetal ions are anions and metals are reducing agents. You can always write these two half reactions, right? A metal becoming a nonmetal, or a nonmetal becoming a metal. You can just write those half reactions out quickly, balance your electrons, and figure out really quickly if you've got an oxidizing or reducing reaction, and therefore an oxidizing agent or reducing agent, if you can't memorize these, which is fine. You don't need to memorize those. Just know how to write the half reactions out and identify oxidizing versus reducing. All right. Make two columns labeled oxidizing on the left and reducing on the right, just like in a redox table, and then working with one equation at a time. If the reaction is spontaneous, then the oxidizing agent will be above the reducing agent on our table. Then we're going to look at the rest of the reactions and we're going to place them accordingly in order. And then we're going to make a redox table of relative reaction. So our last two examples give similar data to what we've been working on in those tables. It just does it in kind of a different way. So here we have our reaction that is taking place, and we can figure out the half reactions from this reaction. So this is telling us that cadmium solid is reacting with the hydrogen ion, and this SP here tells us that this is a spontaneous reaction. Because this is a spontaneous reaction, we know that our oxidizing agent, oh dear, that's too big, our oxidizing agent must be above our reducing agent on our table. So when we're writing our table, our oxidizing agent should be above our reducing agent for a spontaneous reaction. Now down here, this half reaction is non-spontaneous. So in this case, we know that we would write our oxidizing agent below our reducing agent on the table. Let's do an example and I'll show you, and this will maybe make a little bit more sense.
Okay, so here we have example 7. So our first thing that we need to do is we need to realize that this is a reaction, and in it we've got an oxidizing agent and a reducing agent, and we need to figure out which one is which. Now, if you can remember that your cation, so this could be any cation, is going to gain electrons and become a metal, okay, or in this case hydrogen. So here this is a gain in electrons, so this is a reduction reaction, which makes hydrogen ion the oxidizing agent. Here we've got a metal, so we're just going to call this Y solid, and it becomes Y2 positive by losing electrons. Loss of electrons is oxidation, which then makes this the reducing agent. Okay, if we were to have anions and nonmetals in here, you would just do these reactions up here to help remind yourself for anions and nonmetals. Okay, but just doing yourself a quick little thing with imaginary compounds or imaginary entities is going to help you figure out which one is your oxidizing and your reducing. So now you can see any cation, right? You remember now that your cations are your oxidizing agents. So let's go ahead and label our oxidizing agents. And then our metals are our reducing agents. So we can go ahead and label everything else as our reducing agents. Now over here, this is telling us if the reaction is spontaneous or non-spontaneous. So if the reaction is spontaneous, then our oxidizing agent has to go above our reducing agent when we make our redox table. So what I do is I make just a little table down here. This side is going to be my oxidizing agents, and this side is going to be my reducing agents. So in this reaction, my oxidizing agent hydrogen is for sure above my reducing agent cadmium. So I'm going to say that hydrogen is for sure above my reducing agent, which is my cadmium, on my table. Okay, so hydrogen is above cadmium. Now I'm going to look here. This is a non-spontaneous reaction, so I know that my oxidizing agent is below my reducing agent on my table. So if I look here, I've already got H positive as my oxidizing agent, and then I'm going to put mercury, which is my reducing agent, above my oxidizing agent on my table. Now I go down here, this is a spontaneous reaction, and here I've got cadmium ion as my oxidizing agent. Now you can see here I've got cadmium as a reducing agent, but I need my cadmium ion, and I'm going to draw it right across, because this is a half reaction. So this is my cadmium cation ion, Cd2 positive, and there's cadmium on this side, right? There's no point in drawing it anywhere else. This is going to end up being a half reaction here. So my cadmium cation ion must be above beryllium on this table. Because we know cadmium ion is already below hydrogen ion, then it makes sense. I'm going to put my beryllium down here. So there's my beryllium solid. Now my last example here, I've got calcium and calcium ion reacting with beryllium. This is non-spontaneous, so my oxidizing agent must be below my reducing agent. I don't have calcium on my table yet. I do have beryllium. My oxidizing agent must be below my reducing agent, so I'm going to put my calcium ion over here. Okay, now what I do is I can just fill in my blanks with my half reactions and have a table completed. So I'm going to do that just in a different color marker here. So if I were to fill this in, here I would have Hg2 positive plus 2 electrons produces mercury. H positive plus 2 electrons, H2, and I'm going to fill in a 2 over here. Cadmium plus 2 electrons, there's cadmium solid. Be2 positive plus 2 electrons, Be solid, and then my calcium ion plus 2 electrons to calcium solid. And now I've created a table, a redox table from these reactions up here. I'm just going to write it over here nicer, a little bit nicer for you guys, and then I'll take a screenshot and show you what the redox table looks like. But here, if I'm wondering if mercury ion is going to react with cadmium, I can see this would be a spontaneous reaction. Okay? Even though I don't have mercury and cadmium as an example up here, I could tell you on a diploma exam that mercury ion would react with cadmium in a spontaneous reaction. All right, let's go ahead and just write that table out a little bit neater than this, and then we'll work on our last example. So here's our table all nicely written out. We can see that our strongest oxidizing agent is on the top left, and our strongest reducing agent is on the bottom right. If we look here, if we look at our first example, just over here again, we saw that cadmium reacts with hydrogen ions in a spontaneous reaction. We go back and look at this. Here we've got our hydrogen ions and our cadmium solid. We can see that hydrogen is above cadmium on this table. This tells us this is a spontaneous reaction. Our oxidizing agent is above our reducing agent. So let's go ahead and do one more example. So similar to example 7, here we've got a couple of spontaneous reactions and non-spontaneous reactions. So why don't you guys work on this one, and then I'll check back with you in a few minutes to see if you guys got the correct answer. Okay, here's our last example for the day. So here we've got cobalt and indium. So we've got our cobalt ion and our indium ion. Remember here, again, you guys can just write yourself a quick half reaction. 2 positive, it must gain electrons to become CO solid. That means gain in electrons is reduction. That must mean that this is our cobalt ion is an oxidizing agent. So this is our oxidizing agent, right? Our metals then are reducing agents. So copper ion, oxidizing agent. Cobalt solid, reducing agent. Copper ion, oxidizing agent. Platinum solid, reducing agent. Okay? So here, our cobalt and our indium are reacting. This is a spontaneous reaction. We're getting products here, and it tells us that it is spontaneous. So we know our oxidizing agent must be above our reducing agent. So let's go ahead and make our little table of oxidizing agents and reducing agents. Our cobalt ion must be above our indium metal. Now here, we've got our copper ion and our cobalt. Now we've got cobalt as a solid, so we're going to trace a line across from cobalt, and we're going to put cobalt solid on our reducing side, because here it's our reducing agent. So we're going to put it in line with our cobalt ion. That's how we would see it on our table. And then our copper ion and our cobalt are reacting. So our copper ion as an oxidizing agent must be above our cobalt solid. Okay? So here we have another spontaneous reaction. Our last reaction tells us here that our copper ion and our platinum ion don't react. There's no evidence of reaction, so this is a non-spontaneous reaction. So that means that our reducing agent must be above our oxidizing agent. Now I haven't left myself a ton of room, but what that means is that platinum over here is above our copper ion right here. So now we can go ahead and rank our oxidizing agents from strongest to weakest and our reducing agents from strongest to weakest in a table. So if we were to draw that out, whoa, throwing pens around here, we would have, I'm just going to do it over here so you guys can see. Right, so we would have our platinum ion plus 2 electrons, would be our platinum solid, and then our copper ion is next. And then we had our cobalt ion. And then lastly, our indium, which I think was 3 positive. So we just draw in our half reactions. This is our strongest oxidizing agent. This is our weakest oxidizing agent. So sometimes a diploma question would ask you to rank your strongest oxidizing from strongest reducing after getting a question like this. They could also, strongest oxidizing to weakest oxidizing. They could also ask you to rank your strongest reducing agent to weakest reducing agent. They could also ask you a question about saying if something like cobalt reacted with platinum, would you get a reaction? And the answer was here, if you had your cobalt ion with your platinum, of course you wouldn't get a reaction here because your oxidizing agent is below your reducing agent. Okay, good job.